Stack is one of the most asked interview question when it comes to DSA interviews, and it is a type of data structure that follows last in first out principle. What do I mean by that? So let's consider a stack of books where the last book placed on the top is the first one to be removed. So last in, first out. That is exactly how stacks work in programming as well. Let's see how this works visually. Did anyone say visual explanation? Well, Algo Agarwal is here. Let's go. So let's take an array with few elements such as 2, 5, 3, 1, 6, and 9. So this will be our example array. Now let's create a stack as well. So stack will look something like this for us. Okay, fine. So you might be wondering, what are all these? So these are all the functions that a stack can perform. So let's have a look at them one by one. So first one is push. So what push does is it basically allows us to push something inside of a stack. So for example, our first element is 2. So we're going to take this 2 and push it inside of our stack. So something like this. So this is the first element of our stack. Similarly, we can push all of these elements one by one. And as I mentioned, stack follows last in, first out approach. That is, the last one to go inside of this stack will be the first one to go out. Some people also call it first in, last out. That is, this first one that is gonna go inside of the stack will be the last one to come out. So let's see this with an example. So let's push all of these elements now. 5, 3, 1, 6, and 9. So our stack is full now. We have pushed all of these elements inside of this stack. Now the next function is pop. So pop is responsible for taking an element out of this stack. So when we run this pop function, this, let's say this 9 over here will come out of this stack, and then our stack will look something like this, right? Now what does peek do? So peek basically allows us to see which element is currently on the top. So right now if we run this peek function, the element on the top is going to be 6 over here. But if let's say we run pop again and we pop 6 from it, now if you try to peek it, topmost element will be 1. Now next we have a function called size. So size basically tells us how many elements are currently inside of this stack. So right now there are 4 elements. So size will give us 4. Now the next function is isEmpty. So isEmpty basically tells us if there's something inside of the stack currently or not. That is, if the stack is empty or not. So if we run this isEmpty, right now you can see we have 4 elements inside of it. So stack is obviously not empty. So this will give us false. But let's pop all of these elements inside of it. So if we run pop 4 times, then it's gonna clear the complete stack. And now if we try to run isEmpty, this is going to give us true. So yep, this is what a stack is all about, and all of these functions are responsible for manipulating a stack. Now let's understand the code for this. So first of all, what I'm going to do, I'm going to declare a class over here. So class stack. So class is basically a template that can be used to create objects in JavaScript. So you're going to know as we go forward, as we implement this stack. So what I'm going to do, I'm going to declare a constructor function over here. Now what is a constructor? Now if you've used something like React in the past, so you know there's a hook called useEffect hook, which initializes all of the variables or whatever you want to do when the component is rendered first, right? So when we will create a new instance of this class, this constructor will be the one to run first. So let me show you. So for example, this dot stack. So what I'm doing over here is I'm declaring a local variable called stack, and I'm initializing it with the empty array. So whenever we create a new instance or new object out of this class, this will initialize a local variable called stack inside of this class, and it will initialize it with an empty array. That is an empty stack. Now, as you saw in the visual explanation, we have a function called push, which is responsible for pushing something inside of the stack, right? So obviously we're going to need some element as well. So I'm going to input this element, and then I will refer to that stack object, this one over here, this dot stack. And since this is an array, so we have an access to the function called push. So we're going to push this element inside of it. So element. So what this will do is this will add this element on the very top of this stack, as we saw in the visual explanation. Okay, cool. Now next comes pop function. So pop, as the name suggests, it's going to remove the last element. So, but first of all, I'm gonna say, if there's nothing inside of the stack, then we are not supposed to remove any element, right? So I'm gonna say if, and I'm gonna just write a comment over here. If this is empty, I'll write the logic for it in just a second. If this is empty, then I'm gonna simply return a message saying stack is empty. But if it is not empty, then I'm gonna simply say return this dot stack dot pop. Simple. Cool. Now what about this logic? So for this logic, I'm gonna implement a function called isEmpty, and instead of this, I'm gonna say this dot is empty. If this is empty, then we're gonna say stack is empty. Cool. Let's write the logic for this first. Simply, how will we know that an stack is empty or not? Obviously, we're gonna check the length of that stack, right? So I will say this dot stack dot length is equals to 0. If it's 0, then obviously it is empty, so we're gonna return it. If it's false, that if it is not 0, if it's more than 0, then we will perform our pop operation. Cool. There's one more operation called peek, if you remember. So peek, what basically allows us to do is, it allows us to see the topmost element currently in our stack. For this as well, we're gonna first check if it's empty or not. So I'm gonna copy and paste it over here. If it's empty, then I'm gonna say stack is empty. Else, we're gonna say return this dot stack. And for the topmost element, what we're gonna do, we're gonna check the length, like the last element of the stack, right? So I will say this dot stack dot length -1. This will give us the last index of the stack, so that is how we can access it. Oops, this will be square bracket, that's my bad. Yep, so this will return us the last element of our stack. But you see, we are writing this again and again everywhere. So instead of this, I'm gonna have a function called size. So size, what it will do is, it will simply return this dot stack dot length, just like that. Now instead of all of those, I will say this dot size. That's more like it. And that is it. That is how simple it is to implement a stack in JavaScript. You don't believe me? Let's try to run this. Okay, so we have this stack class, right? As I mentioned, this is a template for creating new objects. Now, how do we create a new object out of this class? I'll say const stack equals, we're going to use this new keyword over here, new, and I will say stack, and that's it. That is what you need to do to create a new object out of it. Now, a lot of you might not be familiar with this class syntax. So if you want me to create a complete separate video on this class, constructor, new keyword, all of these things, just let me know in the comments down below and I will come up with a separate video on this topic. Cool. So we have the new object for the stack. Now we have the access to all of these functions over here. So initially our stack is empty, right? So I'm going to say stack dot push, and I'm gonna push, let's say 10 to it, and let's push a couple of more elements. I don't know, let's say 69, 420, and now let's have a peek on what our stack currently contains. So I will say stack dot peek. Okay, let's try to run this. Node stack implementation, and yep, our topmost element is 420. And what if we remove this element? Then our topmost element will be 69. So if you remember, when we pop it, we return the last element, right? So I'm gonna say const stack dot pop, and if we run this now, you see we got 420 popped from the array. Now if we try to, let's just duplicate it, and I'm gonna put it over here. Now you're gonna see this will give us 69, just like that. Let's try to empty the whole thing. So I'm gonna say pop again, it will remove 69. I'll say pop again, it will remove 10. Now if we try to peek, I'll just keep the last peek and remove all of these. So we popped 420, 69, 10, and we try to peek over here, stack is empty. What if we try to pop again? Stack is empty. Okay, let's just add some custom messages. Can't perform peek for this one as well. Can't perform pop. Now if you try to run this, you see can't perform popped, and when it comes to peek, it won't be able to perform the peek. Now what if we try to use isEmpty function? It will give us true because it's obviously empty, right? So yep, true. And let's try to know the size of our array. I'm gonna first know the size of the array over here when it's full. So it was initially 3 and at the end it was 0. So yeah, that is how easy it is to implement the stack in JavaScript. So I have one homework for you for this question. I want you to create a function which will return us all of the elements of this stack. Maybe that function will, loop through all of these elements. That's on you. So you need to create that function over here, probably print stack. And whenever I try to run this, you're gonna print all of the elements inside of this stack and comment down below what your implementation was. Now next we're going to discuss some of the most asked interview questions on stacks in our DSA interviews. But before moving forward, if you're preparing for your front-end interviews and you would like me to help you in your front-end interview preparation, just click the link in the description down below and book a one-on-one call with me. We're going to discuss tips, tricks, and I'm going to give you a proper roadmap, a lot of resources on how you can prepare for your front-end interview effectively. I will tailor your interview preparation according to the timeline you tell me, like whatever time you have. I will try to give you the best possible preparation guide for your front-end interviews. Or if you feel like you're already prepared but you want me to take your mock interview, I have a front-end mock interview call as well. So click the link in the description down below and book a one-on-one call with me. Alright, so the first question is, given an integer string s, we are supposed to reverse the order of the words. So we have the input here, the sky is blue, and we are supposed to reverse the order of the words, not the actual words themselves. So the order is the sky is blue. So the output will be blue is sky the. Similarly, if we have an input such as this, which has trailing spaces, like spaces before and after it, we are supposed to trim them and we're supposed to reverse the order of words, like hello world will be world hello. Similarly, we have an word like this, sentence like this, a good example. So as you can see, we have more spaces in between this. So what we will do, we will remove all of them and we will keep only one single space. So when we reverse this, it will be example good. So let's take an example. So we will take, let's say this over here, the sky is blue. So what I'll do first is I'll split this sentence by white spaces. So I will say this string dot split. And what this will do is it will convert it into an array. So something like this, the sky is blue, right? So we've got this array. Now we're gonna create a new stack array over here, right? You can use this one as well, but since we're understanding stack, I'm gonna create a completely new array for our stack because we are going to manipulate that stack, right? So that is why I've created a completely new stack over here. Now we're gonna copy all of these elements inside of this stack. Okay, we have copied it. Now next, what we will do is we will iterate through this stack, and one by one I'm gonna pop all of the elements like blue, and then I'm gonna add a white space in front of it, and then I will say is, then I will say sky, and then I will say the, and I'm popping all of these elements and I'm adding it to a completely new string, right? So this is how we will reverse this particular string, right? Let's see with our code. So reverse word equals a new function s. It takes an input s, right? So let's create our string. So I will say split the string. So I'll say s dot split with white space or just normal space. Now I will create a new stack. So stack equals empty array, and then I will copy this whole thing. Let I of split s inside of this stack, right? So I will just say stack dot push. I'm pushing every element inside of this stack. Now just this small disclaimer for those of you who think that there might be a better way of doing this question. Yes, obviously there is a better way of doing this question than this, but since we are required to use a stack over here, that is why I've created a separate variable for stack. Don't worry, in my strings video I will show you how you can do this question much more effectively, but for now we are going to use a stack over here. So okay, we have all of the elements inside of this stack. Now I'm going to create a new final string over here where we're gonna insert all of these elements and reverse them, right? Reversed elements basically. So cool. I'm gonna run a while loop over here until the stack length goes to 0. So stack dot length. Now inside this while loop, I'm gonna say const current element, and I'm gonna pop the current element from the stack. So stack dot pop. So whenever we pop it, as you know, it gets removed from the stack and the stack length decreases. So that is why we are measuring the stack length over here. Now after this, I'm gonna say if there's something inside of the current, then just add it to the final string plus equals a white space plus the current element. Cool. So yeah, that is what will add it to our final string, and we will have the final string at the end. Now I'm going to return this final string and I'm going to trim it and I'm going to remove any spaces around it, right? And that is basically it. Let's just try to run this. Reverse words, I'm going to use multiple, like example, the sky is blue. And a good example, let's see if we get what we expected. And obviously we're supposed to console log both of these. Let's try to run this. Okay, we got an error. Yeah, this should be let. Yep, you see, the first got reversed, then the second got reversed as well, and all of the trailing spaces and the spaces in between got removed. So let's take this code and run it in lead code to see how well our algorithm is. Submit this. And yep, you see our algorithm beats 32.72% of other solution. That's fine, because right now we're supposed to understand how a stack works, and if we're supposed to do it with stack, how we're going to do it, right? And as I mentioned, I'm going to show you a better solution for this same question in our strings video. Now, what is the time and space complexity for this? So as you can see, we have this first for loop which runs through the length of this array, and then we have a second for loop which runs through the length of this stack again. So the time complexity will be O of 2n, and we don't consider constant, so we're going to ditch 2, and so the time complexity will be O of n. Similarly, our space complexity will be the same, because we're creating a new array over here, right? And this one array over here as well, so it will be 2n's, which we're going to ditch the 2, so it will be O of n space complexity as well. Now, if you haven't yet subscribed to our channel, hit that subscribe button right now before moving forward, because it motivates me to make more such videos and bring you all this level of good quality content. Alright, so our next question is valid parenthesis. So what does this question say? We're given a string s containing just the characters these opening bracket, closing bracket, open curly brace, closing curly brace, and open square brace, and closing square brace, right? And we are supposed to determine if the input string is valid. And we're supposed to determine if the input string is valid. Now, how will it be the input string valid? The open bracket must be closed by the same type of bracket. Like if this bracket is open in the string, it should be closed as well. Open bracket must be closed in the correct order. That is, if this is open, this should not be closed first. This should be closed first. Only then this should be closed. If this is open, this can be opened after it, but this should not be closed. The first bracket to be closed over here should be this one itself. If some other bracket opens and then that bracket closes, that is completely fine. So let me just explain you with the example, then you'll know. Every closing bracket has a corresponding open bracket of the same time. So yeah, that's the same thing that I said. So let's see. In the input, this is opened and this is closed. So this is completely valid. So this is output true. This is open, closed, open, closed, open, closed. Yep, that is also true. Now in this one, you can see this is open, but the closed one is this some other type of bracket. So this is false. So let me actually give you another example. So let's say these brackets exist between this. So if we have any open parenthesis and then we have a open square bracket, and then that square bracket should close first before this one, or else, as we saw earlier, this should have been closed before it. So what I'm trying to say is that these should be in the order. So when we try to write code, right, let's say for example this code over here, you can see this bracket is open and then this bracket is closed. This closed bracket does not signify this open bracket, so that is why this is in perfect order. This was open and this was closed at the very end, right? So this is how we're supposed to write the logic for this algorithm. So let's see what we're gonna do. So we will simply first take a empty stack over here, right? And what we will do is, let's say we're taking this example. Now we will iterate through this string and we will pick one by one, like all of these brackets one by one. So first of all, we have picked this one. Okay, we will check over here. This is our stack. So we will check over here if this is an opening bracket. Yep, it is an opening bracket. If it's an opening bracket, I'm just gonna push it inside of our stack. Cool, we have pushed it inside of our stack, right? Now again, we have checked, okay, it's again an opening bracket, fine, we will push it inside of our stack, that's okay. But as soon as we encounter the closing bracket, what we will do is we will pop this stack and we will check what is the last element over here. Is it an opening bracket of the same kind? If it's a square bracket closing, like square closing bracket, I want the same type of opening bracket. Only then this will be popped, and then we will be able to verify this is a valid parenthesis. So here we will pop this last element. So we have popped this last element and we have compared it with this closing bracket. Yep, it was closing bracket of the same type. So yeah, that's fine. Cool. We will move on to the next one. Okay, we have got opening bracket again. We will again push it to this array over here. Fine. Now next, we got this closing bracket. But what is the last element inside of the array? Is it the opening bracket of the same kind? Yes, it is. So we will pop this. Now again, moving on to the next, closing bracket. Okay, let's check the last element of the stack. Yep, it is of the same kind. So we will pop this one again. And yep, we got the empty stack at the very end. And we have verified all of these brackets. So we will return true. Let's understand it with our code, right? So I'm just gonna create a function called const is valid. Let me just make this function over here. Cool. This will take a string as an input, and I'm going to create a stack inside of it and initialize with an empty array. Now I will run a for loop throughout this string. So for loop will start from 0. It will go to string, s dot length. Let me just remove this. Yeah, s dot length and I plus plus. So to calculate the length of a string, it's similar to the array s dot length. Now, as we get the first character, I'm gonna say const char. And how do we take the first character of a string? So I'm just gonna say string of I. So this is how we can access the first character of a particular string, just like an array. Now, since we have the access to the first character, we're gonna check if the char that we have over here is equal to an opening bracket or not. So is it this, or is it this, or is it the curly brace, right? If it's any of these things, we're just simply gonna push it in the stack. So stack dot push, as I explained it earlier. So char, right? But what if it's not that? Else, if. Now we're gonna check if it's a closing bracket. So if I'm gonna copy this, I'll just reverse all of these. If it's a closing bracket, then what's gonna happen? Now first thing first, I'm gonna check one thing, if the array stack has something on it, because obviously, as I mentioned, before popping it, we are supposed to check if it's an empty array or not. So I'll say if is the stack empty, is empty. So I'm gonna create a isEmpty function over here as well, and I'm gonna provide it with the stack, right? If it's an empty stack, so I'll say const, I'm gonna return false. So let me just write this isEmpty logic, and this is gonna be nothing, just it's gonna take an array and it's gonna return us the length. As if you remember in this part right over here, that is what we did. We were just returning the stack dot length triple equals to 0. That if it's 0, it's gonna return false. If it's not 0, it's gonna return true. So fine, we have checked. If it's not empty, then we're gonna pop the last element. So const top equals stack dot pop. We've popped the last element, and now we will check if char is equals to closing bracket and top is not equal to parenthesis. So basically we will put all of the possible combinations over here that we need to check. So give me a second, let me just write this real quick. Yep, just like this. It's gonna open a curly brace. So let's see what we have done over here. So if char is a closing bracket and the top is not the same kind of closing bracket, or if it's a square bracket, it's not the same kind of square bracket, and if it's a curly brace and it's not the same kind of curly brace, then that's a problem, right? We're gonna return false. Then that means that our question has instantly failed, right? Our validation has failed. So then we're gonna return false. But if we get everything at the very end, like if we reach to the very end with an empty array, like the empty stack, so we're gonna check return is empty, and we're gonna give us the stack. If the stack at the very end is empty, that means we have verified all of the brackets and removed them from our stack. So then this will return true, else it will return false. So Let's just try this out. We're gonna create a string over here, such as this, and we're gonna provide it to the isValid. Cool. Let's node to, yeah. Yep, you see, it's true. But what if we remove one of these brackets here? Now try to run this. Yep, you see, we're gonna get false. Awesome. Let's try to take this code real quick and throw it inside of the lead code. Okay, let me paste this, submit. And amazing, you see, this beats 56.3% of other solution, and the space beats 97% of the other solution. That's amazing. And the time and space complexity for this will be pretty straightforward, because as you see, we are doing one only single for loop over here. So time complexity will be O of n, and the space complexity will be O of n as well. Yep, just like that. Great. So that is it for this video. If you like this video, give this video a huge fat thumbs up. And if you haven't yet accessed our complete data structures with JavaScript playlist, click this card above my head or the link in the description down below.